Question 16 is a speed, distance, time question. Okay, so our clues for it being a speed, distance, time question, as we can see, Savio leaves his house at 7:30, so we've got some time in there to drive to work. He drives a distance of 50 miles. Savio thinks he drives at an average speed of 40 miles per hour. If Savio is correct, at what time will he arrive at work? Okay, so as soon as we see these keywords, the speed, distance, time, that's when we know we should be writing down our speed, distance, time formula. So there's a few ways of trying to remember this. So some people will just remember the main formula. So speed is distance divided by time. And then from there, you can manipulate it and change it so that you can get different ones. So like this one, we need the time. So some people would then go and say, okay, we want time. So let's take that across. So speed times time gives me the distance. And that means if I take the speed across, what I'm going to get is time is equal to the distance divided by the speed. Okay, so some people would remember it like this. They might remember the main formula and then work down to get the one that you need. So this one, we need the time. Another way that lots of people remember it is you can use one of these triangles. So you could say, so it's a triangle like this. So speed, distance, time. So you just remember what it looks like. You would draw it on your paper. And then we could say whatever we needed here. So on this one, we want the time. So we ignore the time and we say time is distance divided by speed. So it's just whatever's left over. Time is distance at the top divided by speed at the bottom. Okay, so whichever way works for you, you are going to get a mark just for being able to put down this formula. So it's really important that you know it. So let's have a go at working this one out. We've got our formula now. Now we can get into it. So Savio, we want to work out first of all, how much time did it take to get to work? So we are going to say his time is equal to his distance, which was 50 miles, divided by his speed, which was 40 miles per hour. Okay, and what we are going to get is that we are going to work out, okay, 50 divided by 40. This is a non-calculated paper. So I would simplify that then and say 50 divided by 40. We could cancel those. Okay, so we were dividing it by 10. So we end up with 5/4. And then you might automatically know that this is 1.25. But if you don't, what you're going to have to do is work out with the division here. So you would have, let's just make a little block here for some space. Okay, what you're going to do is you're going to say 5 divided by 4. We know it's going to be a decimal, or we think it's going to be a decimal. So we're going to add in decimal place straight away and some zeros. And then how we work this out is we always say, how many times can 4 fit into 5? So it can fit into 5 one time, and there's a remainder of 1. How many times can 4 fit into 10? So the 1 and the 0. So it fits into 10 twice. And there's 2 leftovers, or 2 remainders. And then how many times can 4 fit into 20? The 2 and the 0. It goes into 25 times. Okay, so 1.25. So that is our division that we have to do there to get this answer. So this is now 1.25 hours to get to work. What we then need to do is work out how long is that actually. So I don't know what 0.25 hours is. So we would have to then work out, let's see. Okay, so we've got 1.25 hours. So we know this 1 is just 1 hour. That's fine. Let's work out this 0.25. Okay, so 0.25 hours, what we would have to do is we would have to multiply this by 60 to get how many minutes that is. Okay, so when we are multiplying with decimals, what I like to do, my answer is going to have 2 decimal places, but in the meantime, I can just ignore the decimals. So I'm just going to multiply normally. I'm just going to say 60 times 25. And I usually use the column method, but whatever method works for you, you do that one. Okay, so we're going to set it out like that. And then we say, okay, 5 times 0 is 0. 5 times 6 is 30. Then next up, I'm in the tens column, so I'm going to add a 0, and then I'm going to say 2 times 0 is 0. 2 times 6 is 12. We can then add these up. So 0 and 0 is 0. 0 and 0 is 0. 3 and 2 is 5. And then 1. Okay, and then remember, we were multiplying with decimals. So I had 2 decimal places in my question, so I need 2 decimal places in my answer. So you always just start from the back and jump 2 spots. Okay, so that means that this 0.25 hours is actually 15 minutes. Okay, so that is important for us. So it means Savio takes 1 hour and then 15 minutes to get to work. We are now going to use this because even though we have done a lot of work, we still need to put this into our answer. So he takes 1 hour and 15 minutes to get to work. So he leaves at 7:30. We want to know what time will he get there. So he leaves at 7:30 plus 1 hour is going to be 8:30 plus 15 minutes is going to be 8:45. And we assume it's AM because it's in the morning. And that is how we do that one. Next up, in fact, Savio's average speed was greater than 40 miles per hour. So actually he was going faster than that. So how does this affect your answer to part A? So actually, Savio would have gotten there before 8:45 because if he was going faster, his speed was faster, he would have gotten there sooner. So Savio would have taken less time. So he would have gotten to work Question 17 is a frequency tree question. In my experience, students are pretty good at these questions, but let's have a look at it, just go through it so you have an example to fall back on. So 72 people did a test. So that is the total number of people. So the total always goes in this first bubble there. So that's the total, 72 people in total. 20 of the 32 adults who did the test passed. So this tells us we've got 32 adults in total. So let's put that in the adult column. And it tells us 20 of them passed. So 20 adults passed. So you can see all of the ones in this top one, they're all the adults. What we can then work out, so frequency trees always add up. So if we just circle these quickly. So the adults, the passed and the fails will add up to 32. Okay, which means pretty straightforward, we can work out. So 20 plus 12 would give us 32. So they expect you to be able to work that out then. And then we can work out, they don't actually tell us how many children there are in total, but we can work that out. So they say there are 72 people in total. So 32 plus something has to give me 72. So 32 plus 40 would give me 72. So I've worked out how many children there are. They say 6 of the children failed, so I'm going to put that in there. And then remember, again, these have got to add up. So we can then say this plus 6 has to give me 40. So that would have to be 34 plus 6 would give me 40. So there I filled in my frequency table. Really straightforward. You would just have to work through it like that, just keep track of the branches. And then they ask us a question based on this. So they say then, one of these people is picked at random, find the probability that this person is an adult who failed the test. Okay, so what we do as probability is we look for this first. So adults who failed the test, let's check how many they were. So we go to the adult branch. Adults who failed is this one here. So there were 12 adults who failed the test. So that is always what we put at the top. So our probability is there's going to be 12 adults who failed out of how many in total? We said there were 72 people in total. And that is going to be. Question 18 is a proportion question. So this would fall under ratio and proportion. The reason we know that, as soon as we see kind of ingredient lists or recipes, we know it's kind of a proportion setting question. So all we need to do is, for proportion questions, usually how I would suggest we break it down is, here we have the ingredients for 10 scones, okay? And so they tell us all these ingredients for 10 scones. And what we are going to be looking at is we want to know how much sugar she would need for 25 scones. So let's just start off with 10 scones and say, for the 10 scone recipe, how much sugar did she need? She needed 40 grams. So my next step would be, let's work out how much do I need for one scone. That's the easiest. Always, if you just proportion, if you just try work out, how do I get to just one scone? Okay, which I know we want 25, but if we got one, it's really easy from there. Okay, so for one scone, what I would do to get from 10 to 1, I would have to divide it by 10, okay? Because 10 divided by 10 gives me 1. I have to do the same then to the sugar. So my sugar, I had 40 grams. I'm going to divide it by 10, and I'm going to get, that gives me 4 grams of sugar. So that is what I need for one scone. I then, for my answer, I want 25 scones. So really straightforward. I'm not working out all the butter and everything else. Just going to work this one out. So for 25 scones, I would have to times this by 25. And so I'm going to do the same to the sugar. So 4 times 25, and I'm going to get 4 times 25 is 100 grams of sugar. And so you can see, really straightforward, we've worked it out. With these ones, they often give us all the ingredients because they want us to do lots of work, but all we need to do is look at the sugar. That's all they've asked for. I hope this helped. 20%. Let me know in the comments if you have any questions. As soon as we see a percentage like this, we want to work out always, especially in an uncalculated, always work out 10%, okay, because that is what's going to help us. So we're going to say, what is 10% of 240? Your trick is, if I want 10%, I could just say 240 divided by 10. Okay, so my quick way of dividing by 10 is I can just cancel one of the zeros. So 10% of 240 is going to be 24. The reason why I do this then is, then if I want 20%, 20% is just double that. So 20% of 240, I don't actually have to work out. I can just say it is 2 times that, double that. Okay, so 2 times 24 gives us 48. So that is what we need to increase it by. So they say increase 240 by 20%. So we're going to increase it by that. Increase means add. So I'm going to say 240 add that 48. Okay, and then you can do it in the column method. So you can write it out underneath each other. You might be able to just do it by sight. So what we're going to do then is we are going to say 0 add 8 is 8. 4 add 4 is 8. 2 add nothing is 2. And so that is our final answer. So 288. Remember, in this type of question, especially because it's an uncalculated, they are going to give you a mark for working out 10%, for working out 20%, and then for adding it all up. If you didn't work out 10%, if you found some different way, they would give you a mark for whatever method, but in this case, this is our method, so that's how we get that mark. Question 20. So the diagram shows 3 identical rectangles, A, B, and C. 5/8 of rectangle A is shaded. So this is 5/8. 9/11 of rectangle C is shaded. And we want to work out what is the fraction of B that is shaded. Okay, so let's work out the part that's left over. I think that will help us to start with. So if this is 5/8 that is shaded, let's do what's not shaded in A first. Okay, so that means this part here has to be 3/8 is not shaded. And we can see that is the same. So this part here, they've shown is the same as this part here. Okay, so that is 3/8. And then same thing for rectangle C, we can have here, if that's 9/11 shaded, so 9 out of 11 shaded, that means 2 out of 11 is not shaded. Okay, which means same thing here, we can see they've shown it's the same size. So this is 2/11 is not shaded. So if we want to work out how much of B is shaded, we're going to say, well, if we have the whole of B, so the whole of B would just be 1. So let's just put that somewhere. So B is equal to 1 whole. You don't need to write the whole. I'm just for the sake of the video. 1 whole. Take away this unshaded part. Take away this unshaded part. Okay. The trick is this is actually then just a fraction question. So it is a bit of a tricky question. They're trying to see if you can figure this out. So you would definitely get a mark for just being able to write down, this kind of thing. What we then need to do is we can't take away anything if we don't have the same bases. Okay, so we are going to say 1 whole, 1/1, take away 3/8, take away 2/11. We need them all to have the same base. So what I would say, all the same denominator. Let's make all of them have 88 as the denominator, because we can easily convert all of these. Okay, so how we're going to convert these is, let's just get a different color. We are just going to do it in here. We're going to make equivalent fractions. So 1/1, I want it to be something over 88. So what we do is we see, what did I do to the bottom? So I went 1 times 88. And I have to do exactly the same to the top. So times 88. Okay, so that's going to be my equivalent fraction. So wherever I have 1/1, I'm going to write 88 over 88. Next up then, we've got 3/8. Again, I want that to be the equivalent fraction. So 3/8, I want it to be something over 88. So at the bottom, 8 times 11 would give me 88. So I have to do the same at the top. So 3 times 11 will give me 33. And now the same as before, wherever we had 3/8, we are now going to say 33 over 88. And then lastly, we need to convert that 11 fraction. Okay, so let's get some space up here. So 2/11, I want it to be something over 88. Okay, so at the bottom, I am timesing it by 8. So at the top, I have to also times it by 8. 2 times 8 is 16. So 16 over 88 is the fraction that we're going to use there. Okay, so minus 16 over 88. Okay, when we are subtracting fractions, what happens is the bottom stays the same, so we can immediately just write the bottom number. The top is what changes. So we're going to have 88, take away 33, take away 16. Okay, let's work that out. So 88 take away 33. 8 take away 3 is 5. 8 take away 3 is 5. Then we're going to have 55 take away 16. We can't do 5 take away 6, so we have to borrow. 15 take away 6 is 9. 4 take away 1 is 3, so 39. So that is what we are left with, 39 over 88. And I don't think we can simplify that one at all. So that is our final answer there for that one. Okay, question 21, they want a stem and leaf diagram. So here are the ages in years of 15 people. Show this information in a stem and leaf diagram. So a stem and leaf diagram, how we draw it is we have a line going down like this. Not quite like that, sorry. Okay, it looks something like this, and then somewhere you have to make sure you have a key as well. Okay, and what we do with the stem and leaf diagram is usually we want to not, so here we've got like 19, 20, 30, so we want to have all the tens on one side, all the units, all the ones on the other side. So, for example, let's say we look at the 19 first. We would say, okay, instead of writing 19, I'm going to write the 10 on this side and the 9 on that side. Okay, instead of doing 27, I'm going to do a 20 on this, 20 on that side and a 7. Okay, so we fill it in like that. The important thing is it has to be, I'm going from smallest to biggest. So let's have a look first at all of our 10s. Okay, so we have, obviously, we've got 19s, we've got our teens, so 10, we've got 20s, we've got 30s, and we've got 40s. Okay, let's fill in now all of our 19, all of our 10s. So we've got 19 and we've got 17. Okay, so we've got to put it in order from smallest to biggest. So I'm going to write 17 first and then 19. So you see, we don't repeat that one all the time. We just read it as 17, 19 because it's in this column, this row. Okay, next up, let's do all of our 20s. So I've got 28, 29, 27, 27, 25, 27, and 25, and 26. Okay, again, we want to go from smallest to biggest. So I'm going to do my 25s first. So I've got two 25s. So 25, 25. Let's just cross them out so we keep track. Then I've got a 26. Then I've got two 27s, a 28, and a 29. Next up then, let's do our 30s. So I've got 37, 33, 37. Okay, so we start with the smallest, so 33, and then two 37s. And then finally, my 40s, so I've got 45 and 47. Okay, so we just do 45 and then 47. So that is how the stem and leaf diagram looks. And then, like I said, they don't give you all the marks unless you do the key. So you would have to say in your key something, you choose any number, whichever one makes sense to you. So I usually just choose the first one. And I'm going to say, if I write it like this, so 1, 7, that means 17. Okay, so you just draw kind of a mini stem and leaf diagram there. That is our stem and leaf diagram. So it's just a way of rewriting data like that. Okay, so you can see they've got a key here and they've actually drawn it for us, so you didn't have to deal with my bad drawing, but you were just exactly like I've done. Okay, question 22. The centimeter grid shows the plan and the front elevation of a cylinder. Okay, so this is the top view and this is front view. And because it's a centimeter grid, that means each of these blocks is 1 centimeter. Okay, so 1, 1, 1, 1, 1, 1. So we could measure across. In fact, let's just do that just so we get a hang of these things. Let's get a red one. So for example, this one, the front view, let's see, the height, this is going to be the height. And all we'd have to do is just count it. Never mind, sorry guys, I'm going crazy. So if we're looking at this from the front, this is going to be our height, obviously. Okay, and we just count. So 1, 2, 3, 4, 5 blocks up. So that means it is 5 centimeters tall. And then usually for a cylinder, we would also need the diameter. So we would say, what is this line going through the middle? Okay, so we've got 1, 2, 3, 4, 5, 6. So 6 centimeters is our diameter. Let's just label that. Okay, that's our diameter. That is our height. Work out the volume of the cylinder. So now you can see why we were working out the diameter and the height. So the volume of the cylinder, give your answer in terms of pi. So they just mean don't work out. You can just leave it in pi. So the volume of any 3D shape is always the area of the base times the height. Okay, if we look at a cylinder, so how it looks is like a toilet roll. Okay, so you would always have to do the area of the base, so the area of the bottom or the area of the top, doesn't matter. So you'd have to do that area, and you would have to times it by this height. Okay, so we have the height. They told us, well, we measured here. The height is 5 centimeters. The area is the area of this circle. The base is a circle. So we have to work out the area of a circle. So area of the base, you have to know this formula. So the area of a circle is pi times the radius squared. Okay, the radius is half of the diameter. So if I wanted the radius, I just want halfway. Okay, so it's 3 centimeters. So radius is always halfway across the circle. And so what we're going to do is we're going to work out our area. So the area of the base is pi times the radius squared. So it's pi times 3 squared. We can work out 3 squared. So 3 squared is just 3 times 3, which is 9. So we're going to have pi times 9. So then if we want to work out the volume, we're just going to say volume is the area of the base. So pi times 9 times the height, which is 5. And then you can just simplify this. So 9 times 5 is 45 pi. Or you can write 45 times pi, but if you really simplify, that's how you're going to write it. And you can see volume is always centimeters cubed. Okay, question 23, we've got an algebra question. So they say, solve this inequality. Okay, so it doesn't matter that it's got the inequality sign. All you've got to do with a question like this is try get all your x's on one side and all your numbers on the other side. Okay, so what we're going to do here, let's start by taking this 27 across. Okay, so we're going to have 7x, then our inequality. If we take minus 27 across, when we take it across, the sign has to change. So it's going to be 8 plus 27. Okay, so the sign changes when we take it across. So it was a minus, now it's a positive. So we're going to have 7x is less than 8 plus 27 is going to be 35. So we get in there, we've got x's on one side, numbers on the other side. Let's just get rid of that 7 now. So if I was on the side, I was saying 7x, so 7 times x. So when I take it across, I need to do the opposite. So instead of timesing, I'm going to divide by 7. Okay, so that means on the other side now, I'm going to have x less than 35 divided by 7. Okay, I was timesing, take it across, now I divide. Which means we are going to end up with x less than, so 35 divided by 7 is 5. And that is going to be our final answer there. So it's just like solving for x, it's just got an inequality sign instead. Okay, question 24, write 124 as a product of its prime factors. So as soon as you see this product of prime factors, that's your clue. We're going to have to draw a prime factor tree. So how you set it out is you write it like this, 124, and we see how can we break this down. So I usually try test, can I divide it by 2 because I want prime factors. So divide it by 2 because that's a prime number, divided by 3 because that's a prime number, or divided by 5 because that's a prime number. So I usually test those first. So 124, let's divide it by 2. So divided by 2, so 2 times, it would be 62. 2 times 62 would give me 124. So that is a prime number, so I circle it, that's a prime factor. Now we're going to keep breaking down the 62. So 62 is the same as 2 times 31. And that is actually as far as we can go because 31 is also a prime number. So we can't break that one down anymore. Once I've got all my prime numbers like this, they want it as a product of prime numbers. So you would say 124 is the same as 2 times 2 times 31. So the product just means write it with multiplying signs between it. Okay, question 25. A delivery company has a total of 160 cars and vans. The number of cars to the number of vans is 3 to 7. So we've got a ratio there. Each car and each van uses electricity or diesel or petrol. An eighth of the car use electricity, 25% of the cars use diesel, the rest of the cars use petrol. Work out the number of cars that use petrol. You must show all your working. Okay, so the question like this, they're throwing a lot of information to you. What we're going to do is break it down step by step. They're asking us a question about cars. So first of all, we need to know how many cars do they have. So let's have a look at this ratio. So we have cars to vans in a ratio of 3 to 7. And they tell us in total there are 160. So as soon as they give us this total like this, what we need to do is then say, okay, 160, we need to work out the total of this ratio. So together, 3 plus 7 will give me 10. And I'm going to divide it. So I'm going to go 160 divided by 10 gives me 16. And that is the number that I need then to use for the actual ratio. So then I'm going to say 3 times 16 will give me how many cars I've got. And 7 times 16 will give me how many vans I've got. All I need is the cars for now. So let's just work that out. So 3 times 16. So okay, 3 times 6 is 18. Carry the 1. 3 times 1 is 3. Add the 1 is 4. So 48. That's how many cars I've got in total. Okay, so let's make a note of that somewhere just so we have it. We have 48 cars. Now we need to work out how many of the cars use petrol. So they say of the 48 cars, an eighth of them use electricity. Okay, so let's just say how many electric do we have? It's 1/8 of the 48. So how we work this out is we say 48 divided by 8, which gives us 6. So 6 cars use electricity. Then we can work out the diesel. 25% of the cars use diesel. How you can work out 25% is you could say 48 divided by 2 divided by 2. That is a way of working out 25%. So 48 divided by 2 is 24. Divided by 2 again is 12. So that's how many cars we've got that use diesel. So then if we want the petrol cars, we just need to work out how many are left. So we could say there were 48 cars. We take away the 6 electric cars, take away the 12 diesel cars. Let's see what we left with. So 48 take away 6 is 42. Take away 12 is 30. So there are 30 cars that use petrol. Okay, so it's quite a scary question in the beginning. We just need to break it down like that, work out what you can, because there's a lot of marks for this one. Let's see, this is probably a 5-mark question. Yeah, see, 5 marks. So if you just work out everything that you possibly can, you'll get lots of marks, even if you don't get that final answer. I hope this video helped. I'm going to make another video with the